Module 4 explains secure hash algorithm. Secure hash algorithm is a digital signature standard. Digital signature is nothing is a process or technique used to identify the authenticity of a signature or a message. Digital signatures are used in Aadhaar card, income, caste certificate, PAN card, etc. SHA-1 is the first version of this standard. This standard takes minimum length of 224-bit message. Okay, so this is a process, and this is a system that produces digital signature. So the input must be about 224-bit, and the output will be 160-bit digest. And digest is nothing but compressed image of a message or compressed message created by hash function. Hash function is a function that transforms the data into a string of fixed size. Any data, the hash function converts any data into string. The first step in the first step is message yum. Message yum is padded or added with length ml. So this is message yum. This is lm. Message yum is added with length lm. The length of the message should be in the range of or should be until 448 mod 512. We have to remember this. The padding bits used for padding should be as low as 1 bit and as high as 512 bits. This padding, this length lm should be in the range of 1 to 512, as low as 1 bit and as high as 512. Therefore, the 64 bit is known as least significant bit. When a least significant bit is added with a message, it must be multiple of 512. Say this is a digital signature message. When 64 bit is padded with this message, then the output must be multiple of 512. After padding, the next step is to convert each block to 512-bit word. Each block to word. Okay, these are words. We have to remember this by heart. This wi is equal to mi, 0 less than I less than 15, and wi is equal to wi minus 3 XOR wi minus 8 XOR wi minus 16, 16 less than I less than 79. Next, the each bit of wi. Next step is each bit of wi must be made with state using the four steps. These four steps. The next step must be performed using the values a, b, and c, and with the function f of a, b, c. F of a, comma b, comma c. A or B or union A or C. First 2 and 4 are similar. A XOR B XOR C. First and 1 and 3 is also similar. A intersection B union A intersection C. Similar till here. And union A B intersection C. This is also easy. 0, 20, 40, 60. 20, 40, 60. And number before 20 is 19. Number before 40 is 39. Number before 60 is 59. And 79. Okay, then the 80 steps are defined as how 80 steps. So we have 4 steps and each step has 40 and 20 rounds. Multiple of 2 into 40. 20 into 40. 20 rounds into 4 steps. 80. 80 steps total. How to write it? R1, R2, R3, R4, R5. Delta R1, R2, R3, R4. 30 here. The message digest is produced by concatenating the values from R1 to R5. The message digest is produced by concatenating the values from R1 to R5. Concatenating means adding R1 plus R2 plus R3 plus R4 plus R5. The message digest is produced like this, right? Not on firewalls. Firewall is a security barrier to screen to monitor incoming and outgoing traffic, incoming and outgoing network data or anything. Firewall accepts and rejects the service or the connection according to some sort of rules. These rules are assigned by the developer of the firewall. Firewalls are like secretary who examines, who protects the access to the network, who examines and protects the access to the network, who can access the network or who cannot access the network. If a person wants to meet HOD, the secretary does certain level of filtering, some basic level of filtering. If a person wants to meet HOD, if a person wants to meet principal, then the secretary performs much different level of filtering, the higher level of filtering. A firewall is placed between an internal network and an external network or internet. Internal network is said to be safe network. External network is said to be unsafe network. The job of firewall is to determine what to let in, what to let out of the network. He has the right to decide who can come in and go out of the network. Three types of firewall are packet filtering, stateful filtering, application proxy server. Packet filtering is a firewall that operates at network level. Stateful filtering is a firewall that operates at transport level. Application proxy server is a firewall that operates at application level. Explain two different kinds of techniques used to protect a network. Two different techniques used to protect network are cryptographic technique and authentication technique. Cryptographic technique is a process of converting a piece of information into some sort of code. Information into some sort of codes, and thereby, if this process is nothing but encryption, cryptography. With the help of encryption, ciphertext is produced. Um, this is encryption. When plain text is entered, it is encrypted and ciphertext is produced, with the help of which an external can't intervene and decipher the text. Converting a piece of information into some sort of code, thereby disabling the intermediator to decipher it, to decrypt it. Only the source and destination can encrypt and decrypt it with the help of cryptographic technique and not any intermediator or hacker. Two types of encryption techniques are public key cryptography uh, and secret key cryptography. The message encrypted and decrypted using same key and our secret key is known as secret key cryptography. When public key is used for encryption of message and when the secret key is used for decryption of message, this type of cryptography is known as public key cryptography. What is elements of network security? What are the elements of network security? There are two elements of network security: confidentiality, authenticity, and integration. Information should be available to only those who have the rightful access to it. Say in a WhatsApp message, if one person sends a message to another, two of them are the authorized to access the information, rightful access. So this is confidentiality, authenticity, and integrity. The sender of message or the message itself must be verified at receiving point. Different attacks. Explain different attacks in each of the following. There are four types of threat to network security: DNS hacking, router table poisoning, packet mistreatment, denial of services. DNS hacking. DNS is nothing but a server that has the IP address for host names. As an user or host many users and hosts are connected to DNS. So whenever a DNS is hacked, large portion of internet is affected. A DNS attack may appear in the following form. So there are three types of DNS attack: information level attack, masquerading attack, information leakage attack. In this form of attack, the server is forced to respond with an incorrect answer. With cache poisoning, like cache is nothing but a small portion of memory or a copy of memory placed in front of memory, so the user can access the information in much faster way, uh, to reduce the time complexity. Whenever the attacker poisons this cache, he inserts fake information into the web cache, which later redirect the user to malicious website. So whenever wrong information is present, the user can redirect to a wrong website. Masquerading attack. In this attack, an attacker poses as a trusted entity in user and DNS server. Say suppose this is a DNS server and this is a user. They both are communicating to each other. So an external agent may intervene in their connection, and he can act as a trusted entity, and in and can obtain all the secret information. He can also redirect the packet to local server. He can also redirect the packet from here to somewhere else, and the information from user to somewhere else. And this is also known as middleman attack. Masquerading attack is also known as middleman attack. Information leakage attack. In this, the attacker sends query to all hosts. Suppose our DNS is present with multiple IP addresses. So an attacker first attack this DNS and obtain all the IP addresses of the user, and he then sends the query to all users with different IP addresses. To different users, he sends a query and find out who is not using their system or IP address. If he finds out that IP address, so with that IP address, he makes use of IP address to make other type of attack. In this attack, the attacker sends queries to all hosts and identify which IP address is not in use. Later, an intruder can use those IP address to make other type of attack. Router table poisoning attack. Router table poisoning is undesirable modification in routing table. So in router architecture, input port, switching fabric, output ports. Output ports. Here we had router processing, which had forward table, which forward table had data of input packets input port and corresponding output port. A router table poisoning is nothing but modification in the routing table. Okay, modification in this table. This can be done by manipulating packets information sent by the router. So this can be done by manipulating the packets that are arriving to a router. This is challenging as wrong entry in routing table may lead to congestion looping, because whenever this packet is manipulated, when this enters into the router table, then the router table gets confused and congestion may happen in a router. Looping can happen in a router, and network partition can also happen. So there are two types of router poisoning attack: link attack and router attack. Link attack. In this attack, the attacker get access to link and thereby modifying routing messages. So there are three routers. They are all connected via link. So when an attacker get access to one of the link, he can modify routing messages from here to here or here to here. If an attacker successfully in place an attack in link state routing protocol, then an router can send incorrect information to its neighbor. So when a link is hacked, a router can send incorrect information to this router, and this router can send incorrect information to this, and this router can send incorrect information to this router, or they can remain silent. So A router can stop packet or drop the packet. In this case, a router can drop a packet or stop a packet may reaching a destination. So if the router stops a packet in this case, then the packet can take another route because uh, there are multiple ways to reach the destination. So link state attack is set not that much harmful compared to router attack. Router attack can affect both link state protocol and distance vector protocol. When a router is attacked, they become malicious. So when a router, so whenever a router is attacked, which are connected to a link, they become malicious. So in the router attack, what happens? If when a router attack has happened, the router can get imaginary links to non-existing routers, which or which can create an which can add a non-existing link or remove an existing link. In this way, a router can ignore update from its router. So when this happens to this router, he can ignore the message coming from this router and this router. When this happens, the operation of network flow is affected. Operation of network flow is affected. This attack, packet packet mistreatment attack. The attack may occur in data transmission. This attack may happen in data transmission. So whenever data is transmitted from source to destination, the attack takes place in between these. The attacker can capture some packets, and mistreat them. This attack may result in congestion, lowering throughput, and denial of services. The following are the example of packet mistreatment. Interruption. An attacker may interrupt a packet and does not allow it to propagate to the destination. Whenever an attacker attacks the packet, he can stop its propagation to the destination. This is known as interruption modification. An attacker attacks the packet and changes the content, or he can change the data. Whenever an attacker attacks the packet, he can capture it and changes its data. Replication. An attacker may attack a packet and replace it. So, first is he attacks and stops the packet or drops the packet. Second one is he changes some data in the packet, or third one is they replicate the packet. Misrouting of packet. An attacker may attack router, changing its router table, which result in misrouting of packet. Changing the route of the packet. Denial of services. It is an attack that prohibits user. It is an attack made to avoid users making use of services. So Gmail is a service, DNS is a service. Whenever these services are attacked, the main aim is to trouble the user. The attacker may not result in information threat or information loss, but can be very much dangerous. When this type of attack happens, there is no danger of loss of information, but it is very dangerous. Usually, denial of services attack are done to email and DNS. In DNS, the attacker would send buffer could cause the buffer overflow, resulting in denial of services. What happens if this is a DNS? So a hacker can send multiple queries to the DNS at a single time, which may cause the server to shut down or buffer overflow. So this is known as buffer overflow. Buffer overflow mostly happens by placing malicious data in the memory. The main of the aim of the attack to disrupt the service provided to the user. The main of the attack is to trouble the user. There are two types of DOS attacks. Single source attack. An attacker sends large number of packets to target system to disable it. Large number of packet to target system to disable it. In this attack, large number of hosts are used to flood uh, un- unwanted traffic to single target. So when a DNS is attacked, he gives wrong IP address of Google. So in DNS, if wrong IP address of Google is given, so large number of people will be directed to wrong website. This is known as distribution. What is cryptography or authentication techniques? Cryptography techniques, not authentication. It is same. Explain different techniques in encryption. Cryptography technique is the process of transforming a piece of information into some sort of codes and thereby disabling the interpreter to decipher it. When plain text enters, it is encrypted with the help of secret key. The ciphertext is created, and the ciphertext is given input as decryption, and then the plain text is created. This is known as encryption. The main function required for encryption of a message is secret key and XOR. A plain text is encrypted. A plain text is encrypted with the help of secret key and encryption modulo. Then the encrypted message is ciphertext, which travels through the communication network. Plain text enter encryption the well, now secret key in encryption module. The message is encrypted and ciphertext is created. Now the ciphertext uh, travels through the communication channel. At receiver, the ciphertext is decrypted. The encrypt description module using the secret key, and plain text is again generated at the receiver end. The two types of encryption technique are secret key cryptography, public key cryptography. Secret key cryptography. In this, the sender and the receiver had agree on a head using same key for encryption and decryption. In this secret key cryptography, the sender and receiver has to agree that they will use same key for encryption and decryption. This is called secret key encryption. Algorithms used for secret key encryption are DES and AES. Public key cryptography. In this, the encryption technique, different keys are used for encryption and decryption. Public key cryptography is more powerful and reliable compared to secret key cryptography. Algorithms used for public key cryptography are RSA Diffie-Hellman. Write the steps involved in DES DES with diagram. Diagram, if we practice 2-3 times, it will be easy. You can understand diagram if you practice 2-3 times. So what is happening is DES is nothing but it performs encryption. So what is happening in encryption process? There are different method. Plain text is entering and how plain text is entered and how ciphertext is created. DES and AES will be telling us that. So plain text of 64-bit and secret key of 56 bits will enter into initial permutation. So this is initial permutation stage. The 64-bit is divided into 32-bit and 32-bit. Now this 56-bit is divided into 28-bit, 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 28-bit. Okay, now this 28 bits are given to rotation. After performing rotation, they have gone to perform permutation, and after performing permutation, this 56-bit key is given to descriptive function F. After given to descriptive function F, and with the help of XOR, all the 64 bits of plain text is permuted and given to an output of ciphertext is produced. There are multiple rounds, so these are total of 16 rounds in DES. So after performing this 16 round, the ciphertext is obtained as output. Begin DES algorithm. Before round 1, all the 64-bit message and all the 56-bit keys are permuted separately. The incoming 64-bit message is broken into 32-bit walls, Li and Ri. This 56-bit key is broken into 28 bits each and half 28 bit. This 56 bit is broken into 28 bit and rotated 1 or 2 times depending on rounds. There are total 16 rounds. All 56 bits of keys are permuted to produce Ki. All these are permuted. All these keys are permuted to All these keys are permuted to produce a key Ki. The next step, in the next step, descriptive function and logic exclusive OR is used. In next step, descriptive function and logic exclusive OR is used, and all the 64 bits are messages permuted, and this is the output. So what are the functions happening in function descriptive function F? Out of 56 bits of Ki, descriptive bits chosen 48 bits. 56 bits are going as input to function. You only chooses 48 bits. Now the 36 bits of Ri 36 bits of Ri are expanded to 48 bits so that it can be performed combined with 48 bits of Ki. So there are 32 bits of Ki is expanded to 48 bits so that it can be combined with Ki. The expansion process happens like this. So there are 8 4-bit chunks. So 8 4-bit chunks. 2, 3, 4, 5, 6, 7, 8, 9, so on. So how a bit is expanded. So if for this bit to expand, the leftmost bit and the rightmost bit is bitted and given here, and the rightmost bit is given here. So in a loop, these bits are expanded from 32 bits to 48 bits. This is what happens. 8 4-bit chunks and then expanded. Each chunks are broken and each chunk is expanded by copying the leftmost and rightmost bit from leftmost and rightmost adjacent chunks. The function also partitions 8 6-bit chunks. Also partitions 8 6-bit chunks. The corresponding 8 chunks of Ri and 8 chunks of Ki are combined to form Ri minus 1 is equal to Ri minus 1 plus Ki. This is a diagram included in DES. This is what are the functions happening before the 64-bit is converted into 32 bits. So initial permutation 64-bit, 64-bit. So this is not 56-bit key, 56-bit key. Initial permutation 64-bit message is gone into its first round. There are a total of 16 rounds. First round, permuted key 56-bit key is here, and it has to go to for descriptive function yes. From here it has to go to function F. This is what happening. So left circular shift is used and it is sent to permuted choice 2, and from 56-bit 48 bits keys are selected. This process happens for all the 16 rounds, and then the 32 64 bits is converted into 32 bits. It is used after first step, so it is used here. So before coming into here first round, the message would have processed many times. So this process is shown. Before 32 bits, what are the things happening? Inverse initial permutation. The input message should be in 64-bit. The input message should be of 64-bit. Number of rounds required, there are total number of 16 rounds. For each round, key is required. The 6 of key is 64-bit. The size of key is 64-bit. Okay, the size of key is 64-bit, and the size of message is also 64-bit. Additional 16 subkeys are required of 48-bit. The output ciphertext must be of 64-bit. You can write this or you cannot write this because our faculty said it is not necessary, but you can write this to improve your marks. 32-bit, 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 32-bit. Left, right, LK, RK, LK, RK, LK, LR, RK, LR, LK, RK. L is given here. You can see this diagram one time. It is easy to remember. See EX, X, XP, X R. Hmm. Write the steps involved in AES diagram. So this is also a diagram included because in the textbook, if you see, these two diagrams are not available. These two diagrams are not available because for 10 marks question, it is not advisable to write only this much. This much will not give you 10 marks. So it's suggest you to write these two diagrams also for 10 marks. The ES algorithm. AES algorithm. Server A has to send some message to server B. So what happens? So first AES algorithm has provided better security than DES. AES supports message of block size. The message should be 128 bits. In DES, the message should be of 64 bits. There are 10 rounds. In DES, there are 16 rounds. There are 44 subkeys required. In DES, there are 16 subkeys required. Each subkey must be of size 32 bit. In DES, the size of the keys must be 56 bit. Each round has 4 subkeys, that is 128 bits. 4 subkeys are used in pre-round calculation. So for each round, 4 subkeys are used. Okay, ciphertext is of 128 bits. So this is also diagram very important. A block diagram, add round keys, add add round keys, substitute key, shift rows, mix column. So it is also easy, you can see one time. Input arrays, output arrays, intermediate result. S00, S01, S02, S03, S10, S11, S12, S13. You can just check it out next time. It is explained Duffy-Hellman algorithm. With example, Duffy-Hellman algorithm is also known as key algorithm or key agreement algorithm. The algorithm works as follows. Select two number Q and alpha. Okay, Q is a prime number, should be a prime number, and alpha should be a primitive root of Q. In example, you can understand it easily. Use a key user A key generation. For encryption, user A must have in some user A should have some key. So first for key generation, you have to select XA. XA must be selected such that it must be lesser than Q. Calculate public key YA. So YA should be calculated using this formula alpha to the power of SK mod Q. And after finding out the value of the key, it must be shared with user B. It must be shared with user B. The same process for B also. Select XB such that XB is less than Q. YB is equal to alpha to the power of XB mod Q. YB is shared with user A. YB is shared with user A. The secret key must be calculated for user A. The formula is K is equal to YB to the power of XA mod Q, YA power of XB mod Q. Consider the two values 7 and 17. Just these two numbers will be asked, and just these two numbers you should remember. Okay, 7 and 17, you have to select these two numbers. XA is equal to 6, where it is less than Q. Less than Q. YA is equal to alpha XA mod Q. 17 power 6 mod 7. So you can Google it out how to find mod, and you can do YA is equal to 1. And we have to find user generation for B. XB is equal to 4, where 6 is less than 7. And no, sorry, 4 is less than 7. YB is equal to alpha XB mod Q. 17 power 4 mod 7. YB is equal to 7. Sorry, 4. Key value of key must be we have to find out. YB power XA mod Q. If we find out K is equal to 1, K is equal to 1, if both are same, then Diffie-Hellman algorithm is correct. Explain RSL algorithm with example. Choose two prime numbers A and B, and we have to multiply. P and Q. P and Q must be and P and Q must be stored in N. P and Q or P and Q first we have to choose two prime numbers, and we have to multiply it and store it in N, and we have to compute with Euler's potent function. Potent function phi of n is equal to P minus 1 star Q minus 1. P minus 1 star Q minus 1. We have to choose an integer E. Says that greatest common divisor of E comma pi n should be equal to 1. Okay. Should be equal to compute D. 1 less than D less than pi n. First we have to select E, which is encryption. Then we have to select D, which is description. It is also same. Same itself. The D star E mod pi n should be equal to 1. Then public key is equal to n comma E. Private key is equal to n comma D. The formula for encryption: C is equal to M E mod n. M is equal to C D mod n. So 11 and 3. These two questions will be asked. Just remember these two questions. P and Q are selected, multiplied and stored in n. Phi of n is equal to P of 1 minus Q of n. 11 minus 3, 3 minus 1, 20. Choosing E. We have to choose E such that greatest common divisor of E comma pi n should be equal to 1. E and pi n should be equal to 1. So just don't make it a mess. Just select 3. E is equal to 3. Remember, E is equal to 3. And first we have chosen E. Now we will choose D. 1 less than D less than 20. D star E mod pi n is equal to 1. So how we have to do it? D. First we have to select, right, 1 to 20. How we got 20? We got 20 from here. See, Euler is 40 and constants. Okay. 2 into E. E is 3. 3 mod 20. Mod phi n is equal to 0. So it is rejected. 4 star 3 mod 20 is equal to 4. This is also not right, because the equation should be D is equal to 1. This must be the answer. Equal to 1. So 7 star 3 mod 20 is equal to 1. D is equal to 7. So the public key n comma I is equal to 33 comma 3, 33 comma 7. So if you want, you can find out this formula also, this equation also. That's it.